today's talk, we're going to be talking about using HashiCorp's Vault secrets management tool to do basically delivery of Secret Zero with OpenShift. And I'll talk about what Secret Zero is and the whole concept of secure introduction as I go through this. First, a little bit about me. My name is Sacilowski. I'm a senior solutions engineer at HashiCorp. You got my email address, my GitHub, not much going on there. I'm also a really big procrastinator. You'll notice this as I go through the slides because I didn't use a template like I was supposed to. So apologize for that. Anywho, what am I going to talk about today? So I gave a nice title, Delivering Secret Zero. What does that actually mean? So with regards to that, we're going to talk about what HashiCorp's Vault tool is in general, kind of just do a really quick overview of what that is. We're going to dive into it a little bit in terms of the concept of authentication, how Vault handles the brokering of different authentication schemes, and how that's used to provide access to secrets. We're going to talk about how that relates to the whole concept of secure introduction, right, and what that actually means. So that's kind of all about setting the context here, and then we're going to dive into the Kubernetes authentication backend and how that specifically relates to OpenShift. And we'll kind of, we don't have a lot of time, so I won't really do a demo, but we'll talk about, I'll kind of go over some code snippets to see what it looks like to set the whole thing up and provide some resources that you could go to later on to actually see it in action. And obviously, we could do some Q&As here. You have my email address. There's some business cards on the desk here. If we don't get to all the questions today or you want some more details on how all this stuff works, certainly feel free to reach out. I love talking about it, so perfect. All right, so what is Vault? How many people here in the room have heard about HashiCorp's Vault tool? Oh, wow, okay, great. How many are using it currently? Okay, awesome. Well, that's, you've heard of us, that's great. So what is Vault? Vault, we kind of look at Vault as trying to address three main use cases when we talk about the delivery of secrets. First and foremost, it's about centralized secrets management. So how are you currently handling secrets in your application infrastructure? You might be embedding some of your secrets in configuration files. Maybe you're knowingly or unknowingly committing them to GitHub. It happens. You might have some disparate password management systems that are used in your environment, so on and so forth. The point is you have a lot of different things going on with various different types of secrets. What Vault aims to try to provide is a centralized location for this, wrapping access control around it, as well as auditing to kind of know what's going on. And we won't go too deep into it here, but I just wanted to kind of make it obvious, and we'll talk about a little bit more on the next slide, is what kind of secrets does Vault actually deal with? And we kind of handle a number of different types of secrets, from static, like key value type things, things that don't necessarily rotate on a consistent basis, but also, more importantly, we like to focus on the whole concept of dynamic secrets, which is really, if you think about a dynamic secret, if you have a web application cluster, each node should not be using a shared database account, for example. You want each node to have its own account in a database, let's say, and you want that to be kind of an on-demand type of thing with the built-in lease, for example, so you could easily revoke. We'll talk more about that in a little bit more detail. All right, so we have our centralized secrets. We have all this. We have this tool where we could put all our secrets. Well, how do we actually access these secrets now, right? We want a programmatic interface for our scaled applications to easily do this, and we want to be able to use various authentication schemes to access them. Obviously, we need proper authentication and authorization. Vault doesn't necessarily aim to be a source of identity. It certainly can, but more importantly, it aims to be a broker of identity, right? AWS has IAM, Google Cloud has IAM and GCE. Azure has Azure Active Directory, so on and so forth. There are all these native built-in authentication capabilities. We want to serve as a broker to those so that you can operate in a fairly agnostic way, but utilize native capabilities where applicable. And then the third use case is really around encryption as a service. We won't go into too much detail on that here. It's Vault's transit backend, but if you could think about it this way, an encryption key is just another secret, essentially. So we have a centralized secret store. We have authentication. Let's move cryptographic operations away from the developers, away from the applications, and offload it to Vault. Applications authenticate to Vault the way they might to obtain any other secret. And they just they offload the decrypt, encrypt digital signature operations to Vault. Could definitely talk about that more later on if you'd like to. Let me know. So these are kind of the three main use cases that Vault tries to solve for. So how do we do this, right? So this is, we like to call this our magic triangle internally. It's a triangle, right? Basically, the idea here is we want to try to represent the overall access flow with how you interact with Vault, how a client might interact with Vault. So to that end, on the top, we have our clients. Now, these could be human operators, developers, any kind of human client, or programmatic clients, containers, virtual machines, servers, so on and so forth. The idea is we have some entity that needs to obtain a secret. And we talked about this a little bit already. On the right-hand side, we have the various types of secrets that Vault can help you with, right? From very generic key value type of secrets to generating AWS API access keys on demand in an ephemeral fashion, essentially. PKI certificates, SSH keys, database credentials, also in an ephemeral way. Again, this kind of encompasses the whole concept of dynamic credentials, providing credentials in a timely on-demand fashion, essentially, and providing a time-bound mechanism around them, managing a lease. So those are our secrets. We have our clients. Well, how do our clients now actually get these secrets? And this is the whole idea of IAM brokering, essentially, that we were talking about earlier, the whole idea of authentication. AWS has its own authentication approaches. Kubernetes has its authentication approach, the whole idea of service accounts, and that's kind of where we'll dig in a little bit more later. Pivotal Cloud Foundry, Azure, all these different platforms and environments in which we operate typically have some native capabilities around authenticating the applications or those entities. So the overall flow is basically, I have a client. It uses one of these authentication mechanisms to obtain an authentication token from Vault. All of these authentication schemes that you see on the left there, essentially the aim is to provide some way to deliver a Vault authentication token. So once the client has that token, any subsequent API calls into Vault to obtain different types of secrets use that token, right? So this is basically a way to securely deliver that initial token, secret zero. Does this make sense? Any questions so far on this whole concept? No, we're good. All right. So again, just to kind of summarize, Vault is all about centralized secrets management. All of our things are dynamic and distributed, or at least we hope them to be. We want to try to remove the human from the flow of having to deliver these secrets. We're error prone, and we don't necessarily scale that well. And again, Vault supports a number of different authentication schemes. All of those essentially map down to the delivery of an authentication token, which is used for all subsequent operations. And then, again, how do we deliver that in a secure fashion? How do we use these authentication schemes for that? So a little background first. Again, I'm kind of trying to provide a lot of context here to see how we get to where we are now. I've done a webinar in terms of the whole concept of app role. App role is another authentication scheme that Vault supports, and it's a fairly generic one in the sense where it can work in a lot of different environments. When dealing with containerized environments, for example, AppRole, before the Kubernetes authentication backend came along, AppRole was kind of the recommended way of doing it, and in a lot of cases, it's still the preferred way. But now you have options, right? So I wanted to segue a little bit just to talk about what AppRole provides, because it sets up certain patterns, certain ideas, specifically around the concept of, trusted entities in your environment. So again, we're talking about AppRole. We're talking about the idea of circle of trust, right? We have systems in our environments that we trust. And we might be using Terraform for provisioning our infrastructure. We might be using Ansible Tower, for example, for configuration management. We might be running a Kubernetes cluster or OpenShift or some version of that, maybe even Nomad, which is a HashiCorp's scheduling tool. Or we might have some various systems for our CI/CD pipeline. Point is, we trust these systems to do things in our environment. Maybe we don't trust them fully, but we have some level of trust to do things. So how does AppRole play into this concept? Well, if you think about AppRole as essentially a username and password for machines, it's kind of easier to understand what we're trying to do here with this whole concept of circle of trust, right? Basically, AppRole splits up the authentication mechanism into something similar to a username and something similar to a password. Basically providing what you need for an authentication through two separate channels. So I might be using Terraform to provision my infrastructure. Part of that process might be the delivery of what's called a role ID. It's a static kind of identifier that identifies a role. Our names are pretty self-explanatory, right? Point is, with a role ID, I can't do anything other than just have this piece of data. It gives me nothing. It doesn't authenticate me into Vault by itself. The other part here is the secret ID, right? So think of this as the password in this whole username password scheme. It's going to be a one-to-one mapping to any client that essentially gets delivered a secret ID. And that might be delivered through some other mechanism. Maybe I'm using Ansible to deliver it, maybe one of my orchestration systems. The point to remember, and this is a lot of detail, but the point to remember is that in and of itself, a role ID or a secret ID gives you nothing. The only time those two things should ever come together are in your target, whether it's your your container, your application on a server. Once the whole provisioning and configuration management process is complete, I have these two values. I can now use it to authenticate to Vault. And the only system in this entire chain that has those two values at one time is the client. So I push it down as far down as possible. Any questions on this so far? Okay, so again, the whole idea here is just to kind of set up some context around how you used to be able to do authentication in terms of containers. And AppRole really is flexible in terms of not only related to containers, but any kind of approach. If you're doing a lot of on-prem stuff, you don't have things like AWS IAM or anything like that. Typically, AppRole is used in those environments as well. The important thing is here, we have to understand that we have to trust something. And that leads me into some of the other authentication capabilities within Vault, and specifically how those are used for the whole idea of secure introduction. So we like to talk about Vault currently, and I mentioned this already, as a broker of identity. So what does this mean, right? We have a whole white paper, and I've linked to it. I have a resources page slide at the end of this that has links to a bunch of these different resources, and we go into a lot of detail there about it. But to summarize, the idea is, again, I want to not restrict myself to one specific environment, right? I want to be able to operate on-prem. I want to be able to operate in the cloud, the various cloud environments, whether public or private. I want to be able to operate, in my Kubernetes cluster, and I want to do this in an agnostic and consistent way, at least in terms of managing my secrets. Again, our AWS authentication backend uses IAM. EC2 instances, Lambda functions, they can all have IAM roles assigned to it. We could actually use that as a source of truth for accessing credentials or secrets in Vault. Azure Auth has a similar mechanism. Azure Active Directory and the more recently announced managed service identities for VMs. Google Cloud has the same idea. And then finally, Kubernetes Auth, right? We have the whole concept of service accounts. So we have a built-in native capability for managing identity within Kubernetes, essentially. So to that end, basically, Vault does provide a Kubernetes authentication backend, and this is what we're going to actually dive into from this point forward. So how does it work? It's actually a pretty simple process, and as part of my admission of being a procrastinator, I kind of started going through this, I don't know, maybe 10 p.m. last night. I'm like, oh crap, I should probably figure this out and really understand how it works. I hope I have enough time to. An hour later, I'm like, oh, it's actually pretty easy. It's a lot easier than I expected, which is great for me because I'm a procrastinator. So how does it work? So we have Kubernetes. Kubernetes deploys pods. Within those pods, I may have one or more containers. These pods are essentially, when they're deployed, they might have a service account attached to it, and basically an identifier for that is a JSON Web Token, a JOT file, right? And that's stored in a secure storage in your pod, and that's available to your containers. Okay, so I kind of understand how the whole service account concept works in Kubernetes. On the Vault side, I enable the Kubernetes authentication backend, and I'll kind of show some code snippets how this is actually done in a bit, but just to kind of give an overview here, I set up the authentication backend. Basically, the way that Vault does what it does in this whole flow is I give Vault a service account that has a token reviewer API permission. So when I set up the backend, I provide that JOT file as well as a CA cert that allows it to talk to my Kubernetes cluster. So I have that set up already. So those are really the two hardest parts. The way everything comes together is essentially a container reaches out to Vault, sends its JOT file for the service account that it was deployed with or through to Vault. Vault takes that JOT file, reaches out to the Kubernetes API, validates it, returns back a token to the container, and then that token is what the container or the application within the container then uses to interact with Vault. Pretty easy, actually, and we're using the native capability within Vault within Kubernetes, instead of writing a custom type of plugin. Does this make sense so far? No questions? Okay. So let's see kind of how that looks in practice when I'm talking about some code. So the first step I talked about earlier is actually setting up the backend on the Vault side. That's really two steps, right? Vault enable Kubernetes backend. That's just saying I want to use a Kubernetes backend. There's no configuration there. The second step is to actually now that I've enabled that connection, how do I tell it to connect, and how do I give it the credentials to connect to my Kubernetes cluster? And really all that involves is, again, when I created Vault, I essentially created a service account for it that has the capability to do token review. So there's obviously a JOT file associated with that. I provide that to Vault in the configuration. I tell it the host name or the URL or how to locate my Kubernetes cluster. How is it actually going to talk to that? And then finally, I give it a certificate, a TLS certificate, so it knows how to that it can communicate, since all my communications are TLS, right? And this is basically all I have to do. This is a one-time setup, really. You do it when you're first setting up your cluster, for example. You don't have to redo this. But this is how we're telling Vault, essentially, to talk to our Kubernetes cluster. Great. So now we have the Vault side of things set up. What do we do next? So I have my authentication method set up. The next step is I want to create policies within Vault. Vault has a number of different ways to do policies, permissions essentially, to access different types of secrets. At the base level, we use ACLs. So all that is I define a path and the capabilities on that path. So in this case, I'm using HCL as a way to define my policy. And I could have any number of paths and capabilities on that. Basically, what I'm saying is Vault is going to deliver a token. Tokens are usually what we attach policies to. And this is how you define some of these policies. So in this case, it's a simple policy. I have my path secret/application, secret/OpenTest. Whoever gets the token with this policy attached can do read and list operations on those paths. Very simple. And then I write it out to Vault. Any questions so far? Okay. And this is where the interesting thing actually, where everything kind of comes together, right? So we've defined our authentication backend. We've defined some policies. Well, how do I bring everything together, right? And this is where the concept of roles within Vault comes into play. Any authentication methods that I mount in Vault, and we've kind of mentioned a lot of different ones, essentially follow the same pattern. I configure the actual connection to the environment that I want to perform authentication against, and then I configure a number of roles underneath that endpoint. And what a role is, essentially, is a mapping from these external entities that I want to authenticate against to policy, one or more policies within Vault, right? So in this case, I'm saying I want to create a demo role. In the case of the Kubernetes authentication backend, I could bind to service account names or service account namespaces. So over here, for demo purposes, I'm just really binding to the default service account. And I could add a number of namespaces if I want to. And here, I'm just putting a wildcard. And then I'm mapping the one or more policies to this specific role. So I'm saying, basically, any container that authenticates to Vault whose JOT file essentially corresponds to the default service account, as well, will get the policies OpenShift test policy, which is the policy that I just defined earlier. And then we have a TTL too. That's time to live for the actual token that gets delivered. Again, all the concept of tokens in Vault or dynamic secrets is essentially built around the concept of leases. Everything has a lease attached to it, so everything is ephemeral. Those are completely configurable, so you could essentially make something ephemeral or something pretty long-lived. And you could have any number of roles underneath this authentication endpoint that's defined. Any questions so far? Sure.
TTL, does Vault somehow kind of enforce it, or it's solely on the client?
No, so Vault absolutely enforces this. So remember earlier I mentioned, we had this triangle. We have our clients trying to access secrets. The way they do that is authenticating through some method to deliver an authentication token. That token is essentially what the TTL is scoped to. So if, as an application, I have this token and let's say it's 3 hours later and I try to do an API call and pull something, well, that token is no longer valid. So Vault is actually managing those leases internally so it knows when a token is expired or not. So you might, for example, in your application, build the logic to renew the token if necessary. In containerized environments, depending on how ephemeral you are, you might, if you have logic that determines that your token is expired, you might kill the container and spin up another one with a new token, for example. Really kind of depends on the life cycle of the container in your application, in your environment.
So for example, if you have an API
yeah.
and use a token, how often does it have to go through Vault? It doesn't have to go every call.
No, right, right.
Within the TTL.
So
But the application itself needs to know, hey, I can only use this token for a couple of hours or something like that.
Well, so that's a good question, right? And that's kind of a deeper discussion around, well, how are we actually, what secrets are we delivering and when are we delivering them, right? Are we, as soon as a container comes up, for example, are we just pulling some secrets at that one specific time and then throwing away the token, and then that's when as long as the secrets live? Don't forget, this TTL is really only scoped to the token itself. Secrets that we're grabbing from Vault using this token might have their own TTLs as well, right? So the idea is you have to look at kind of your whole application delivery lifecycle. How often am I renewing these tokens? And I'm happy. Let's get through this, and we could kind of talk, more afterwards in the Q&A about more details around that, right? So again, multiple roles, and then finally, this is the actual authentication stage, right? So I said I created a role for my default service account. This first line over here is just me grabbing that token, right? So I'm using the OC, the OpenShift command line client to actually pull a token. You might have that already embedded in the container, but this is kind of just for demo purposes. And then we do an API call. Here we're using the Vault command line interface, but everything in Vault maps to an API call. We're hitting the auth Kubernetes login endpoint, and we're just sending the role that we want to authenticate against and my service account JOT file, right? And that's it. And then Vault does what it does in terms of validating that JOT file, making sure that the role is a valid one. We get a token back, right? We see that the token duration is 2 hours, so that's the time to live for that token. And we see the policies that are scoped to that token. So default is just something that every token gets. I need to be able to inspect myself. And then the other policy that we define through the role. So now you can envision your application might be making this API call. It has its token now. Now I could use it to pull secrets from the KV store, my database credentials, whatever I've defined as the scope for that token, it can now do it, right? And kind of going back to your earlier question, I might do it once, or I might do it continuously on, based on however long my secrets live, but I can only do it for 2 hours unless I renew the token. In this case, by default, the token is renewable up to a certain maximum amount of time. And that might be a little too in the weeds for this discussion, but I'm happy to talk about it, otherwise afterwards. Does this make sense? Kind of from a high level. Again, there's going to my next slide in terms of references. So I didn't want to get too deep into the weeds here with a full-on demo or things like that. I kind of wanted to set the context. There's plenty of resources out there to help with this whole process. Kind of what I use as a source for myself kind of going through this was there's a great blog post on the OpenShift blog called Vault Integration Using Kubernetes Authentication Method. Gives you really nice step-by-step process of doing this. What I wanted to provide was the entire context around the idea of secure introduction of these secrets and how Vault helps you do that, right? Some of the other resources here, I mean, the top ones are really around just kind of generic information. In terms of app role, I did a webinar a while back with app role using Terraform and Chef, so you could review that if you'd like. Kind of covers a lot of the same idea, same information. But the really important things to look at are these last three links here. So that blog on the OpenShift website, as well as we have some internal guides that we've put together using Terraform, for example. So the first one here is basically, it's a repository that uses Terraform and Ansible to provision an OpenShift cluster. So for those of you that might not know what Terraform is, it's our infrastructure provisioning tool. Actually, question, who here has heard of Terraform before? Awesome. Who's using it? No? Okay. All right. Hey, there you go. So I get asked a lot of times, well, if I'm using Ansible, why do I need Terraform? And it's really around kind of using the best tool for the job, right? Terraform is really good at providing your infrastructure provisioning, and Ansible is really great at doing configuration management. They're not mutually exclusive. You want to use the best tool for your job, and this repository basically shows you how to do that and set up an entire OpenShift cluster. And then the last link over here shows you how to actually use Terraform and Vault to manage your Kubernetes cluster. One of the aims of Terraform is to provide an agnostic way of interacting with your platform, your environment, whether it's AWS, Kubernetes, OpenShift, so on and so forth. So this repository kind of shows you how to do a lot of that. So these, I'm happy to. You have my email address, teddy@hashicorp.com. Feel free to get a card. And I could send you these slides out too if necessary and go into more detail about any of the things I spoke about.
So Sarah, at the talk at 11, talked about automating your DevSecOps. So if you can automate the way containers call the database, you've taken the human element out of that, and you really speed yourself to market. And it's a different way of securing your applications. It's not by a firewall anymore. It's how do we do it dynamically across multiple clouds? And that's really, this is a great tool to automate that entire process.
Any other questions?
So what kind of identity stores it can integrate with?
Sure. So let me do this. Let me go back to this slide right here. Okay. So obviously, I mentioned earlier, we kind of interact with both human-oriented and kind of programmatic types of applications, right? So you see, when talking about identity stores, from a cloud-native perspective, AWS IAM, Google IAM, or Oracle's version of their cloud identity. Azure, is Azure there? Azure is right there, yep. Azure Active Directory, along with the managed service identities that are now embedded in your VMs. So those are really great for kind of programmatic access, but we also integrate with AD, LDAP, Okta, and more coming. So that kind of centers around the whole concept of human-oriented access.
How does it work with two-factor authentication, for example, like multi-factor authentication?
Gotcha. Good question. Right. So let me preface it by saying everything that I spoke about during this presentation so far has really centered around what's available in open source. You can go ahead and download it. You could do everything we just talked about. To answer your question, I have to talk about enterprise. So this is not a sales pitch or anything. So just making that clear. But the idea here is the enterprise version of the tool provides a capability called Sentinel, which is kind of, we talked about ACLs as one form of policies. Sentinel is more fine-grained types of policies. Really quick example of that is if I'm using LDAP as a human-oriented identity authentication store for administrators, let's say, I could use Sentinel to say, well, anyone hitting the LDAP authentication backend has to use MFA, so I could tie into Okta for that, and has to be coming from specific CIDR blocks, let's say, right? Administrative subnets, as an example. We could do a lot of fine-grained stuff with Sentinel, so that's one way that you'd integrate MFA. It's really dependent on what of these, I guess, backends support MFA, and there's some more available on the enterprise side in terms of MFA, since that's not a core capability.
Like, for example, does it integrate with RSA security?
I think we do, actually, yeah. Let's talk offline about that, because I don't want to get too far into the weeds on enterprise stuff here, and I just want to, I'll verify that for you. So, definitely grab a card after this and let's talk more.
So you mentioned about the encryption as a service.
Sure.
Is there an alternative for KMS or?
Yeah. So right. So this is an interesting question, right? Because KMS is good. KMS is for AWS, right? Like, so there's certain trade-offs, right? If I want to do EBS volume encryption, I can only use KMS. But if I have other encryption types of use cases, encrypting data in transit as I'm writing out to my database is a common one that we see. Absolutely, right? So I have my client. It authenticates to Vault using one of those methods. The encryption key is just another secret, right? But I'm not actually delivering it to my clients. What I'm doing is I'm basically, through permissions, allowing that client to do encrypt, decrypt operations according to policy. So I never have to actually distribute my encryption keys. Vault holds those, and I'm using the whole concept of policies and permissions to determine what actions I could offload.
For that encryption key also, it is a time how long you can specify.
It can be, yeah. We do rotation, versioning, so on and so forth.
So how does it tie with TLS certs, for example?
Sure. Vault can operate as a certificate authority, whether a root, internal root certificate authority or intermediate, or both, right? So the idea with the PKI backend, for example, is the same way I might attach a TTL to a database credential, I can attach a TTL now to my PKI certificates. So instead of depending on revocation lists and so on and so forth, I could now rotate my PKI certs, I don't know, weekly, daily, as often as I want. It's totally configurable by me, as long as I have a way for my application to authenticate to Vault. And that might be using one of those capabilities there, for example. Yeah, we're time. Sorry. So yeah, feel free, again, Teddy@HashiCorp.com. I have cards here. If you think you might ever have some questions, feel free to grab one. And I'll be happy to, I like talking about our stuff, so I'll be happy to talk about it. Hopefully this was helpful and enjoyable. Thank you.